A good day to you. Thank you for your time. My name is Tony, one of the instructors of this competency. In this very short lecture, we will be providing a quick introduction to AI and also a very quick introduction to what machine learning and supervised learning is. So without further ado, we jump straight in. Okay, so let's get started. By the end of this lesson, you should be able to differentiate between general and narrow AI, describe the different definitions of narrow AI, appreciate what these expert systems are, pinpoint where machine learning sits in the context of narrow AI, and know the difference between classification and regression. So we hear the words narrow artificial intelligence thrown out very often nowadays. What then is artificial intelligence? What does it actually mean? We put it in context of two big camps first, which are the general AI and narrow AI. So in general AI, you often have seen in movies like Terminator or even like the Avengers. You have Jarvis in Iron Man. Terminator, where the person being able to, or rather a robot, being able to move, think like a real person, or your C3PO, they seems to be able to do whatever that the human is able to do. These are typically known as general AI. The other contrast is narrow AI, where you have very specific tasks that the AI is supposed to do. In our everyday life, we work with so-called spam filters in our Outlook or in our email accounts. Heard of AlphaGo in chess? They do a very, very specific task, which is playing chess. Even the Siri on your Apple phone is considered a form of very narrow AI. What happens is that if you take the model that was built on playing chess, you put it into a spam filter, it probably won't be working very well. And the reason being is that the model was only trained on a very, very specific task. And if you put it out of the context, it won't be able to perform as well. In the recent years, the bulk of, I would say, advancement has been in the field of narrow AI. And that will be where this competency will be largely focused. There are four definitions of narrow AI. Let's go through them one by one. These definitions do not come from me. They come from a very established author. The title of the book is Artificial Intelligence, a Model Approach, one of the very long-standing books in AI. The first is Thinking Humanly, where we talk about cognitive modeling. In this form of narrow AI, it kind of tries to model AI after how the brain works. It has been said that the field of neural networks actually originated, at least in theory, from this field of thinking about narrow AI. The second is known as thinking rationally, where we try to distill AI into certain mathematical formulas or first order logic. Having said that, it is probably very difficult for us to be able to define everything in terms of equations. For example, even think the definition or rather the mathematical equation for the number 8 is something that is really, really hard for us to define. The third, you may have heard of this, acting humanly. What you see here is that of a Turing test. In a Turing test, what it means is that you have a human person that is interacting with either a computer or another human. It is said that the Turing test has been passed if this subject is unable to tell whether is A a human or is B a human. At this point, where C is unable to tell whether A or B is a human, and that will mean that he has passed the Turing test. This used to be a huge parameter of what AI is. Being able to fool a human being into thinking that it may be another human. However, things have changed up and down over the last few years. And one of the examples that I like to give is that if you're building a plane that can fly from point A to point B, you want to build a plane that can bring you from point A to point B in the fastest and the safest manner. You do not need to build a plane that can fool a bird into thinking that the plane is another bird. So once again, I say the main thing about the Turing test is that it seems that it needs to fool a human into thinking that the AI is another human. So in the context of building of aeroplanes, if I want to build a plane from point A to point B, I want to build a plane that can bring me from A to B in the fastest and the safest way. I do not need to build a plane that can fool a bird into thinking that the plane is another bird. So if we take the example of the chess player AlphaGo, all of us know that AlphaGo is not a real human, but all of us have no doubt that it is a piece of AI. So we realize that the Turing test in some aspects may not be as relevant anymore. However, in today's time again, in the realm of generative AI, we start to see the relevance of it in certain areas. So, for example, if you are building a chatbot, that is it able to pass the Turing test or not? If you are generating certain audio or certain image or videos, are they able to pass the Turing test? So those are the realms of the Turing test suddenly becomes extremely relevant once again. And the fourth definition is where we will spend most of our time on, is on acting rationally. When we talk about agents, agents that maximize their expected value of their performance given what they currently know. And for this, I will put two fields into this acting rationally, which is expert systems and machine learning. So as a recap, we have two definitions initially, general AI and narrow AI. And we have said that general AI is really like a supercomputer that is able to do everything that the human being is able to do. And narrow AI where it's specific task. In the narrow AI, we have four different definitions. Thinking humanly, thinking rationally, acting humanly, acting rationally. And we will be focusing primarily on acting rationally. In acting rationally, we have two things, expert systems and machine learning. We'll talk more about these two things along the next few slides. First, we talk about expert systems and how it's very different from machine learning. In expert systems, we usually, it was actually very popular in the 80s or maybe even the 90s, where we have domain experts to derive certain handwritten rules. And these rules are what will determine the outcome of a certain task. So, for example, if the task is to be able to detect the number 8, so the expert may say that, oh, to detect that, I may want to split it into two parts, and I will say that I will try to detect if a circle is on top or if a circle is below. If both are present, then I will say that has a high chance of being the number 8. Of course, such a superficial rule, even to many of us would be really not very good, not very good. An example, if I have a number that looks like this, all of us can tell that it is the number 8. But if we apply the rule here, probably won't be able to say that it's the number 8. Similarly, if I have a mahjong tile, we all know that this is just, it means the 2 in the mahjong tile. But in fact, if we apply this rule, it may be understood as is the number 8. So this simplistic rule suddenly fails for many instances, and that was exactly what people found out, or what industries found out of how expert systems usually fail, even when the task becomes a little bit more complex. And that is where the term machine learning came up with. Okay, what machine learning actually does is the following. Okay, in expert systems, we have an expert that comes up with the rules. Okay, so the data comes in, an expert comes up with the rules, and then the machine then predicts out the output. So that's a very typical expert systems are driven so-called a manner. In machine learning, what happens is that we don't have the rules yet. So we use the data, we use the expected output, and we use this to generate the rules. Once again, we actually don't have the rules yet. So we use the data, we use the expected output, and from this tool, we then use it to generate out the rules. In the context of this image, what we are trying to say is that this is the data. The data is a set of handwritten numbers. So these are 0, 0, 0, 0, handwritten 1, 2, 3, all the way to 9. This is the data. This is our expected output. Meaning that if I were to see this set of numbers, I will have to predict that this is the number 0. If I were to see this, I have to predict that this is number 1, 2, 3, and so on. So from the data, from the expected output, we are supposed to, or rather the machine is supposed to generate out the rules. This particular form of machine learning is known as supervised learning, which also happens to be the competency of this. We'll be going into this a little bit deeper over the next few sessions. And by the end of the entire competency, you should have a very firm understanding of what this is all about. Other than that, we have supervised learning and also reinforcement learning. Supervised learning is another part of the competency in this micro-credential. So I won't talk about this for today. Reinforcement learning is a slightly more complex technique, and we will cover it in this micro-credential. Finally, we have two things. One is classification and regression. This is in the context of supervised learning. So classification means we want to predict a class. Regression is predicting a certain number. So for example, if we want to predict whether will it rain or will it be sunny, that is a form of classification. So it's either raining or sunny. So that is classification. If I talk about regression, it is predicting the rainfall. So it is a certain number. So the amount of rainfall that is going to be falling in maybe the month of August or the month of December. Okay. So for today, we covered the following. Firstly, what is general AI and what is narrow AI. In the realm of narrow AI, look into 4 different forms. We have thinking humanly, acting humanly, thinking rationally, and acting rationally. We focus only on acting rationally because acting rationally is based on past data. In acting rationally, we have two things: expert systems and machine learning. We talked about how expert systems are unable to deal when the situation gets a little bit more complex. Hence, we focus only on machine learning. In machine learning, we then have again 3 different fields: supervised learning, unsupervised learning, and reinforcement learning. And for this competency, we'll be focusing primarily on supervised learning. So I hope this gives you a good introduction to what AI, supervised learning, machine learning is. And I look forward to going through the rest of the material with you. Thank you.